I think they signed some sort of agreement saying they weren't going to say anything.
Oh, that's great.
Well,
You guys are good, man.
each question.
You guys are really good.
Bailey needs to work on pacing and testing, right? Or do you just use every minute for? Okay. So guys, the one real question taking us through a couple of different problems involving the angles, the arcs, the different things that we talked about with this. Again, I think maybe we might do a scrimmage today just so that I make sure I get all of you guys before we go on break and forget everything anyhow. Sorry, I have stuff in your way.
That's not bad.
Why would you just skip this class?
So yeah, he knows how important it is to be here.
My only ride.
Okay.
Then you should just skip school.
It's just one day of school.
All right. All right, so guys, we're gonna talk, they want the measure of arc AC, and they want the measure of FD. So those two arcs there. So now there's two different problems going on this screen. We're using central angles over here, and then we're using inscribed angles over here. So noticing the difference between those two. So in this problem, the arc, so like CD, what's the arc CD gonna be?
100.
It's gonna just be 55. If it's a central angle, the arc and the angle are the same measure, okay? So that means this is 35. So if I want to figure out what FD is, I should be able to do that because this is 180, right? So I have 180 minus 55 minus 35.
90.
We get 90?
Yes.
92? 90. Yeah, how about 90? Yeah. So 90, and that's for FD. So 90 degrees. How are we going to figure out AC? Yeah, go ahead.
100 negative 55. Minus 55.
Okay, so we have, hopefully you guys notice we have vertical angles here. So this is also 55. So to figure out the other side, again, going around this way, this is 180, and we're taking away that little 55. So I believe we end up with 125 there?
Yes.
Yeah? Okay. So remembering the difference between central angles and then inscribed angles. So this next one is an inscribed angle. So they want the measure of angle S here. So angle S is this angle here. And that's what we call the inscribed angle because it's not centered in the center of the circle. Now, I have the fact that this is going to be 180 here. So do I know R to T? Do I know that little chunk?
Yes. 180 minus 48.
180 minus 48, yep. So for that we get 132, right? I believe.
130. Yes.
Okay. So then when we go to find that angle that's across from it, this angle is across from that arc. This is where that arc is going to be double that angle. So to figure out that angle, we have to take half of 132. And what do we get then? So we get 66 degrees because it's half of that 132. So kind of taking us around the shape and knowing different things about these angles based off of the measurements they give us. And so kind of remembering the difference here. Okay. All right. So, we're learning 3 new rules today. Yep. Wait till we have a break. So, we're going to learn 3 new rules here today. Or I guess, yeah, there's 3 major rules. There's more than drawings of those, trying to show you guys different ones that go with this. So, what we're talking about here today, again, finding measures of angles based off of the way the drawing is going to be given to us. So, the first one we're going to talk about is when we have a vertex on the circle. So I'll show you guys an example of this. And actually, this rule we've already done before, I realize. I feel like we're repeating what we've already did, and that makes sense now. So vertex on the circle. So if I have angle 1 here, and this is arc AB. Again, we learned this last class. What do we know about the measure of angle 1 compared to arc AB? It's going to be half. So the measure of angle 1 is going to be half of arc AB. So that's a rule we already knew from last class. So that is not new to us. But I'm going to show you guys one that looks a little bit different. Is what if the angle is kind of like on the edge of the circle? So let me show you guys that. So if I have a line here, so draw like a tangent line. And then we're going to draw just a line going up this way. If this is A to B, that arc still connects those two, but this angle 1 would be right here. And that rule still applies. So if the vertex is on the circle, this is the rule we're going to use. And again, we already did this one, that it's half of the arc that it goes with. All right, now I do want to make sure that you're clear on, again, and I talked about this in the warm-up, I talked about it last section with our notes. You probably have a little bit of space underneath your goal here. So if you guys could take a minute and just remind yourself of a central angle again. I feel like I've showed this a bunch of different times.
Excuse me.
Yep.
Can you please show again the...
I'll come back to it. Hang on.
Okay, thank you.
So I'm going to call this angle 2 here. I'm going to call this CD. So remember the central angle, angle 2 is just going to equal the measure of the arc CD. So this is what we talked about in the warm-up. So when it's a central angle, that arc and the angle are the same measure. So again, this we've used throughout the chapter, and I just want to make sure that's clear that those two are the same. So again, that's a review idea. That's not new today. So going back to the one, look at this is the one here. When the vertex is on the circle, the angle is half of the arc. So it could be, look like it's inside the circle, or it could just be on the edge of the circle. It's always half of that arc. And we'll see more examples of that in a little bit. Yep.
Our test is after spring break, right?
Yeah. So what I was telling them before was that we're going to start on a chart before break, but we still have a couple sections we have to learn after break. it probably won't be for a couple weeks, so, because we come back from break, and then we have a 4-day week when we come back from break, because of Good Friday. I know, it's been a while. I mean, not complaining, but it definitely makes you feel like when we have a bunch of full weeks, we're gonna be like hanging on for dear life. All right, our next one here. We're gonna talk about when the vertex is in the circle, but it's not at the center. So our next one here, the vertex is in the circle, but not on the center. Because if it's the center, then we go back to our rule up on the top. So what we're going to do is we're just going to kind of draw an X in this circle. And I'm going to call this angle 3 that we're going to try and find. And I'm going to label these, we'll call this R, L, H, S. I don't want to use the same letters in every example, so just try to come up with some different ones here. So this one's not on the center. So angle 3 is not just the same as that arc. So when it's inside the circle like this, we have to use a different rule. So the measure of angle 3 is going to equal half of the two arcs added together. So this is kind of crazy, so let me try to show it here. So this arc and this arc added together but cut in half is going to be the measure of that angle. How someone figured this out, kind of crazy. So it's going to be half of arc RH plus arc LS. And for this test, you guys, we're going to end up with either some kind of note card or cheat sheet or something. There's a lot to remember in this chapter, so just so that you guys have a heads up on that, I will give you guys some sort of, like, note card or something you guys can use. What? Me? I mean, that's what I do in my pre-calc, or maybe we'll use the chart. I don't know. We'll figure it out. There's just a lot of rules to remember with this. All right, our next one is when the vertex is outside the circle. So let me show you guys what this looks like. So we've had the vertex on the circle, in the circle, now outside the circle. So, and again, I'll draw 3 different pictures of what this looks like. So we can kind of draw a V. It looks like a superhero symbol or something. And then I'm going to call MATH. All right. So different rules for this one because it's a different situation. So I'm going to call this little angle down here angle 4. So the measure of angle 4 equals half of the two arcs subtracted. But the way we're going to subtract them is we're going to subtract the big one minus the little one. Oops. So MA minus TH. Half of MA minus TH. And the other two drawings, I just wanted to show you guys another couple of versions of this, the way this could look. So another one is it could be a tangent line. Whoops, not the arrow there. With a secant line. So again, here would be our angle 4. Here would be our M. Well, this one's kind of a weird one. This would be like A. And then this would be like T. Math. So in this case, it would be this, and then going here. So we'd subtract those two. So I usually think about this, I'm subtracting the big arc minus the little arc. And then our last example of how this could look is like two tangent lines. If I could draw tangent lines. So remember, tangent lines just go off the edge of the circle. So that should just touch it rather than going through it. And again, this minus the red in this case.